You might not know it, but these are potato plants. They're part of a research project that's looking closely at their genes.
So essentially we're trying to get the blueprint of potato so that first of all we can understand what's going on and then of course be more efficient in how we could engineer better potato.
After all, potatoes are critical. In fact, they are
The fourth largest crop in the world, and it's grown on every continent except for Antarctica. So other than the big three, which would be maize, wheat, and rice, which we all know are important cereals, potato is the next most important crop. And so it's a major nutrient source for not just us here in America, but also throughout the world.
Professor Robin Buell is using the Human Genome Project as a stepladder to learning about potato genes.
Right away, we're just trying to get the instruction book for a normal potato. So once we have that, we would hope to then make either more disease-resistant potatoes or better quality, nutrition quality, other ways to grow potatoes so that we don't have to use so many chemicals. So one way to clearly help the environment would be to have a potato that's more resistant to diseases so you're not having to apply lots of chemicals to the plant. So that would save money for the farmer, plus save on the environment.
The Human Genome Project was groundbreaking in helping to unlock the secrets of our DNA, the human jigsaw puzzle. Professor Buell says this study is groundbreaking as well.
And so now what we're doing in potato is taking technology that's already been established, methods that are established, and applying them to potato. So it's groundbreaking for the world of agriculture and potato, but in and itself is just application of established techniques to this species.
She estimates potatoes have about 40,000 genes. That's a lot to look at. To give you a little perspective, we humans have about 20,000 genes, about the same as a roundworm. Just something to think about. She and her colleagues hope their research will lead to better crops, more disease-resistant potatoes, and better nutrition around the world. She says it's great that MSU is in this for the long haul because it's not going to happen overnight.
It takes 10 to 15 years to get a new variety conventionally onto the marketplace. And so I think my goal is to facilitate, the users, the breeders, to be able to use this data and then make improvements on a much more efficient basis.
And the fact that a big public university is doing it means everyone, everywhere can benefit from the findings.
A lot of potato breeding in the United States is done in public enterprises like universities, and that allows certainly for open access to these kinds of materials. And if everything's restricted to a private company, then you're only going to get things out of that are interest to them and their shareholders. And I think it's a balance, right? I mean, companies certainly do have shareholders and market share, and that's what they need to focus on. But then you need to have these open enterprises where people are doing work for the common good, right? So all of our data from the Potato Genome Project are available for people to use.